Hey class, I'm back. Um, from earlier, we did graphing of exponential function. Now we're gonna solve these exponential functions. Okay, we're gonna solve exponential equations, and the thing about solving exponential equation is you want to get an exponential on each side of the equation, but you want to make sure that when you get an exponential function, they both have the same base on the left that is on the right. Okay? So this is where I say we must get the same base on each side of the equation. So we can use the following rule to solve it. And the following rule says that if a raised to the x equals a raised to the y, then guess what? If they have the same base, you can set the exponents equal. Okay? So let me say it again. We want to apply this rule that if a, or property, if a raised to the x equals a raised to the y, and they are the same base, we want to apply the rule that says that we can set the exponents equal to each other. Okay? So when we're solving these exponential, we are trying to get them to have the same base on each side. Now, let me talk about a base. What a base is, you all. I'm talking about some number that I need to raise to a power that will give me another number. Okay? So that's what I mean, base. Like this thing, they're the same on each side. I can take that same number, raise it to some power, and get the other number on the other side of the equation. Now, I want to show you an example of what we're talking about also. Here, just trying to get a base. Like you have 1 over 81. You're trying to figure out, how do I do this? How do I do this? One way you could do this is that 1 over 81, that means your exponent right here, right now, is positive. And if you want to flip it, if you flip it, it becomes the opposite exponent, opposite sign. So this could flip to 81 raised to the negative 1. These are equivalent to each other. Saying 1 over 81 is the same thing as 81 raised to the negative 1, right? But what if I didn't want to use 81 as a base? Can't we rewrite 1 over 81? 1 over 81, if we write it, can't I rewrite that as 1 over 9 squared, right? I could rewrite that as 9 squared. 1 over 9 squared, right? I can. But if I want it not to be a fraction, I can flip it at this point. I can now flip it and it gives me 9 raised to the negative 2. So 1 over 81 equals 81 raised to the negative 1, and it equals 9 raised to the negative 2. Okay? Because that's a base. Now I'm going to highlight the base for you. If you needed a base, one of the base would be this. Your base is here, 81. Another base for this one is 9. Okay? Now, what if I want to break this down one more time? 1 over 81. Another way I can get 81 is saying 3 to the 4th power. So I can write it as 1 over 3 to the 4th. That's another way to write 81, right? 3 over 4. But if I'm looking for a base and I don't want it to be a fraction, I can flip this and I can get a positive 3. But then when I flip it, remember my exponent to go opposite would be negative 4. So guess what? This 3 to the negative 4 equals 1 over 81. Okay? Once again, let me highlight for you my base. This would be my base. So 81 has several bases. It has 9, it has 3, just depending on what on the other side of the equation. Now, I wanted to show y'all how to write this because when we do some of these, we may have to do this. We may have to flip them. And you might get a negative exponent, or you might be flipping a negative exponent where it's positive. So just keep that in mind. We're trying to get the same base. We're trying to see if we can get the same base on each side of the equation. Now let's solve these. Now remember, you got to get the same base. That's what we're trying to get the same base. Take that number, and can we raise it to some power for each side of the equation. Let's try it. Now, look what I said. Solve these exponential. First one, 1 over 3 raised to the x. Now, just like 1 over 81 here, right? Like just like 1 over 81, like this 1 over 81, right? It's raised to the first. I can flip it and write it like this. So I can flip this 1/3 and write it 3 to the negative 1. I can do that. Watch what I do. So I get 3 raised to the negative 1, right? I got that. That's what 1/3 is. X still on the outside equals 81, okay? But you all, if this base over here is 3, can I make this base over here 3? Yes, we can. We know that 3 raised to the 4th power will give us 81. So it will have the base of 3. But let me tell you this. You have a power raised to a power. Power raised to power. Power rule says you multiply exponents. So this becomes 3 raised to the negative x equals, I just said, 81 is 3 raised to the 4th. Now, perfect. Didn't I say we want to get the same? We want to get the same base on each side. This is the base, this. So once we get the base on the side, guess what we do? Set exponents equal. So negative x equals 4. Final answer would be x equals negative 4. That would be a final answer. Number 2, 25 raised to the x equals 125. 25 raised to the x equals 125. Okay? We trying to find the same base. I need something, not that I multiply it, but I need some number that when I raise it to a power, it's going to give me 25. Take that same number and raise it to a power, I get 125. I hope you all are thinking of thinking of 5. You cannot use 25 here. Yes, 25 go into 25. And yes, 25 go into 125. But you can't raise 25 to any power and get 125. So you have to use 5 here. Okay? So you would say 5 raised to the second power. You got to write it like that. The x on the outside equals what? 5 raised to the third power here will give me 125. Now, what rule I told you? This is power rule for exponents. It says multiply exponents. So I get 5 raised to the 2x equals 5 raised to the third. This is exactly what I want. I want the two sides to have the same base. So now I could just set the exponents equal. 2x equals 3. Solve this, x equals 3 halves. Okay. Hope you're following along, okay? Next one, you all. Number 3 and 4, you all. I have 2 raised to the x plus 4, and then I have 8 raised to the x minus 6. We got to get the same base on each side. Now, one side is 2, okay? So 2 is the base for that side. But the next side is 8. And 8 is just the base for that side. We need to make sure to have the same base on each side, okay? So we got to find a base here. I hope each one of you are saying 2 is the base, because that's correct. 2 will be the base for each side because I can raise 2 to a power of 3 and that will get me 8. So I can make this a base too, okay? Let's do it. 2 on the left-hand side stays the same, 2 raised to the x plus 4. And then we get 2 raised to the third right here that represents 8. And then we got x minus 6 on the outside. You got to do it like that, okay? Now, this, again, power rule of exponents, we multiply. But here we distribute. 3 goes here, 3 goes here. So let me do it. I'm just rewriting 2 raised to the x plus 4 equals 2 raised to the 3x minus 18. Okay? Because you have to distribute to both things. Now, we have the same base on each side, you all. Perfect. Same base on each side. So now we can set x1 is equal. I can say x plus 4 equals 3x minus 18. Now, let's solve this. It doesn't matter what side you put x on. Does not matter what side you put the number on, as long as you solve it for x. I'm going to move 3x and I'm going to move 4. If I move 3x, I bring it over here, I get negative 2x. If I subtract 4, I get a negative 22. When I solve this, x equals 11. That's what I get, x equals 11. Okay? Hope you understand that one. Okay? Next one, number 4. 32 raised to the x and then equals 16 raised to the 1 over x. We need a base, you all. I need some number that when I raise it to a power, it's going to give me the number on the left. I'm going to take that same number, raise it to another power, and I'm going to get the number on the right. Okay, that's what we're going to get. So I hope everybody's figuring out. Most of y'all said what? 8, 4? 8 and 4 cannot work here because I cannot raise 4 to some power and get 32. You can't raise 4 to a power and get 32. 8 doesn't work here because if you raise 8 to a power, it will not give you 32 or it won't give you 16. Okay? So the only one that can work here is 2 again. 2 raised to the 5th give me 32. 2 raised to the 4th raised to the 1 minus x, sorry. Now, remember I say this is power rule. This is what you got to do. And now over here, you got 2 terms. Now, remember, you got to distribute this here, distribute this here. So let's do it. 2 raised to the 5x equals 2 raised to the 4 minus 4x. Now that we have both sides equal to each other, like base are equal to each other, let's set the exponents equal. So we get 5x equals 4 minus 4x. Now let's solve this. I'm going to move, add 4x over. I get 9x equals 4. When I solve this, I get x equals 4/9. Hope you all understand these 4. Now I'm going to do a couple more. Do a few more. And let's do number 5 and number 6. Got a couple. I think we just got these last 4, so we good. You all, we got fractions as our base. And there's nothing wrong with having a fraction as your base. So we got 2/3 as one base, and then on the other side, 9 over 4 is another base, you all. So we got to get them the same. Can 2/3, give us 9 over 4? No, I mean if you raise 2/3 to the power, can you get that? No. If you raise 2/3 to the second power, it will give you 4 over 9. Okay? It doesn't give you 9 over 4. So what we will have to do, you all, is I would tell you, let's break this part up right here. Let's break this right here. Let's break that up. Okay, so let me do this. 2/3 right here. I'm going to put this in parentheses. X plus 2 equals, right? I'm going to break 9/4 up. And I'm going to break it up to 3 over 2. And you know what? If you squared this, this is what you get. Right? That's what you would get. Okay? I'm just going to do that right now, you all. But you all see now, it looked like we would have the same base. But not quite. If we flip this, this will help us. If I put the 2 at the top, I'm talking about the right-hand side. If I put the 2 at the top and the 3 at the bottom, that means I'm flipping it. That means I got to flip my exponent, meaning as it has to change to its opposite. So let's do it. So I have 2/3 raised to the x plus 2 equals, if I flip this now and go to 2/3, remember the exponent changes. So it says -2, and that's what you have. And then you have the negative x on the outside. Now you all see we have the same base. And the rule says if you got the same base, then we can set the exponent to equal. So let's do it. We got 2/3 raised to the x plus 2 here. Then look on this side. We got to multiply these. We get a positive 2x, right? So let's do it. We get 2/3 positive 2x. Right? Because a negative and a negative give me positive. Now look what we have, you all. We have everything. We got the base. Sorry, not everything. We got the base on each side like we wanted. So now we can set exponents equal. Let's do it. X plus 2 equals 2x. Now, if you solve this, you could bring x over and you can solve. And we get x equals 2. X equals 2. Hope everybody see that. And I give you this one with a fraction so you know that sometimes you may have to flip it. Okay? Now let's do this one. Let's do this one right here. We have 1,000 raised to the negative x equals 10 raised to the x and then minus 8. Different root, you all here. Now, can we get a root that they have something in common? If you look at 10, 10 is the lowest one. Do 10 have something in common with 1,000? Can I take 10 and raise it to a certain power to get 1,000? That's what you're asking yourself. Okay. Now, we can. I can take 10, raise it to the third power, and get me 1,000. Okay? So I raised that to the third, and then I wrote what was on the right hand side because it already had a base of 10. Now remember, you all, we have this. We got to multiply those. So I get 10 raised to the negative 3x equals 10 raised to the x minus 8. Now, since we got the same base, we set exponents equal to each other. Now, if I was solving this, I would subtract x over. That would give me negative 4x equals negative 8. I'd get x equals 2. Now, I want to do one more, and I'm going to do number 7 because I want y'all to explain this. You all looking at 1 and 4, and you're probably thinking, well, what's the common base between 1 and 4, you all? That's what you're probably thinking. Well, the common base between 1 and 4 is 4. Because remember, anything raised to the 0 power equals 1. So I can replace this 1 with 4 to the 0. Anything to the 0 power equals 1. Now look, all I got to do is multiply these. Right? Because that's the rule. Look what I get. 4 raised to the 0 equals 4 raised to the 2 minus x. Same side. Same base. Now we set these equal to 0. 0 equals 2 minus x. we get the x equals 2. Now I'm stop right here because I did 7 of these. I think you all should be good with the same base.